Welcome to EDU World Space.
So we're given the circuit in figure 25.30, except that the 5 ohm resistor is now replaced with an unknown resistor of resistance R. And I've done a little bit of relabeling of the circuit, and I've put all the numbers that were given here on the right hand side. So the EMF is 16 volts. R1 is 1.6 ohms. This is the unknown resistor. R2 is 1.4 ohms. E2 is 8 volts. And the resistor that was 9 volts here, I just call it RBC, and again maintain its value. And we're also told another new feature of this problem is that there's an ideal voltmeter that's connected across BC, and it reads 1.9 volts rather. And so I've just written here that VBC is 1.9 volts. And we're asked to find in part A the current in the circuit. So finding the current in the circuit, we can use this equation right away, that VBC is equal to I RBC, right? And from here, we can find that the current is VBC over RBC. And we're given both of these quantities. So we have 1.9 volts divided by 9 ohms, which is equal to 0.21 amperes. Now we're going to move on to part B of the problem. Okay, in part B, we're asked to find the resistance R, that unknown resistance. So we're going to make use of the fact that when you go through the circuit, the total, if you make a complete loop in the circuit, then the total, the sum of all the voltage drops is equal to 0. So if we start with the battery, and then we encounter the voltage drop IR1 for that battery, plus minus IR, and then minus IR2, and then minus E2. That minus IR, was it BC? That's 0, right? So then let's do this. So E1 minus E2 minus I times R1 plus R2 plus RBC is equal to IR. So I just collected this term, and this term because they all have I in common, but I want to find R, so I left it alone and I just moved it over here. And then we can solve very easily this equation for R, which tells me that R is E1 minus E2 over minus I times R1 plus R2 plus RBC over I. And then that's equal to 16 volts minus 8 volts minus 0.21 amperes times 1.6 ohms plus 1.4 ohms plus 9 ohms divided by 0.21 amperes, and that gives me a resistance of 26.1 ohms. And now we're going to tackle C on the next page, part C of the problem. So in part C, they're asking to give a plot of the potential rise and drops in the circuit, and they cross-reference figure 25.20, so you can use that as a reference. So figure 25.20 as a reference. All right, so here we have 16 volts, and let's start at point B over here, put A somewhere over here, and C somewhere over here, and so we kind of, that should be a straight line. It just kind of looks horrible. Let's see if I can undo that. Okay, so pretend that's a straight line, and then you go a little bit, and then from the R1 resistor, you get a drop, and then you're kind of constant a little bit again, and then you hit the resistor R that we just found, and then you're constant again, and then there's a bit of a drop from R2, and then there's a big drop from E2, and you're constant, and then there's another big drop. So this is from RBC. This is because of E2. This is because of R2. This is because of R. And this is because of R1.